Okay, number 8, a student prepares a solution of lead 2 nitrate containing 50 grams completely dissolved at 20 degrees Celsius. The solution is A, unsaturated, B, saturated, C, supersaturated, D, concentrated. Well, we can eliminate answer choice D because that's just not one of our vocabulary words. Then we have to practice here writing our chemical formula just like number 7 above. Lead nitrate, lead is Pb. And remember that Roman numeral tells us that that's +2, okay? Nitrate is NO3, okay? And then the charge on that is -1. Crisscross drop, the chemical formula is Pb. And then since NO3 is a polyatomic ion, you put it in parentheses, 2. Okay, so Pb2 on the graph, or PbNO3 is right here, okay? So when it says 50 grams completely dissolved at 20 degrees, here's 20 degrees, okay? Actually, let me erase some of this because it's getting a little messy. Here, let's erase this graph so we can see better. Okay, so 50 grams, which is here, that dot's here, and 20 degrees Celsius, okay? There's that dot. The line is here. Remember, when the point is below the graph, that's going to be an unsaturated solution. If the point falls on the line, it's saturated. Above the line, supersaturated. All right, number 9. When half a liter of a 12 molar solution is diluted into 1 liter, the molarity of the new solution is, that's this formula, M1 V1 equals M2 V2. It already says molarity of the new solution, which means I'm solving for M2. Okay? So the original molarity is 12 molar. And then V2 and V1, we need to figure out which one is which. Remember, of is that connector word, okay? So if it's saying half a liter of 12, that probably means I need to put half a liter here. So half of a liter, okay? And then I need 1 liter solution. Okay, move the 1 over so I can isolate M2 by itself. Okay, so then in my calculator, I do 12 times 0.5 over 1, which is 6 equals M2. Okay, so my molarity is 6. Okay, let's look at number 10. Let me erase what I did so we can better see it. Okay, number 10 says, what is the concentration of a solution of 150, that should say grams, of copper chloride? Molar mass is 95.2 in 15 liters of solution. So, wow, this is a 2-step triangle question. Because if I have grams of copper, and they gave you the molar mass, which was nice of them, and then liters, I know I need to get concentration. And we know that the unit for concentration in chemistry is molarity. So if I have molarity triangle, sorry, that doesn't look good. Let me try and erase it, make it look nice. Okay. keep it red. Molarity, liters, mole on top. So if I want concentration, I cover up the M, that means I need mole over liter, but I don't have moles. I have 150 grams. So I need to do the other triangle that will give me grams. I have that, molar mass, and mole. Okay, so I'm going to use this triangle, mole, so I can use it over here in conjunction with molarity and liters. So it goes like this. I have grams over molar mass, so I do 150 grams divided by the molar mass, 95.2. Okay, that's going to give me moles. Okay, so do that in my calculator. I get 150 divided by 95.2. That gives me 1.57 as my mole. Okay, now I'm going to take that mole, okay, and I'm going to do moles over liters to give me molarity. So 1.57 moles, which I just found, divided by the liters. 1.57 divided by 15 gives me 0.104 molarity. Now, when I get this answer, it seems like there's a rounding error somewhere in this, okay? So you have to be a little flexible with this exam, okay? If you're getting 0.104 as your answer, look for the closest number. That's obviously D, okay? So just keep that in mind. All right, let's move to number 11. Let me just erase the work from the previous question. It says, what is the concentration of a solution which contains 1 mole of calcium chloride dissolved in 2,000 milliliter solution? Well, again, this seems pretty popular, and it's probably giving us a hint. Concentration means molarity, right? So the molarity triangle that we just used in the previous question, mole, molarity times liters. Okay, so if it's telling me 1 mole dissolved in 2,000 milliliter solution, this is liters, so I have to turn this milliliter into liters. To do that is pretty easy because it's 2,000 milliliters times 1,000 milliliters. Let me erase. Sorry guys, gotta keep it clean and organized. Set up your ratio, 1,000 milliliters over 1 liter. So that means basically I'm doing 2,000 divided by 1,000, which is going to give me 2 liters. So back to that molarity triangle real quick. Mole, molarity, liters. So I do 1 mole divided by 2,000, not 2,000, bad Miss Woodzicki, 2 liters. Well, we just figured out. Okay, guys, 1 over 2 is 0.5. Answer is A, 0.5 molarity.